Hi friends, let's start solving more and more questions, hoping that you're familiar with most of the topics by now. So in this question, what they have is a product of these two polynomials they have given in series expansion. You see how the series is looking like. A naught plus a1x if you start expanding plus a2x square like that. Similarly, the series expansion of this is given to you like the coefficients of b naught, b1, b2 and so on. They're looking for what is this value. So what do? We just try to figure out numerator separately and denominator separately, and then we will divide it later on, right? Okay, so let's get going. So in the numerator, what do you think this whole thing is? This there are double summation there is, right? So one summation I will write like that. S varies from 0 to n. Can you open the second summation and see what is this? Start from r is 0, plug in the value, you get b naught, right? Then b1, and up to what you have to keep on moving? Up to the higher limit, right? 2s. So up to b2s. That is your numerator. Now, do we know this value? Yeah, can you figure out? So who is going to help you? This. Okay, how? You just plug in x is 1, right? You just put x is 1. Okay, what do you get? You see, on the left hand side, you get 1 plus 1 plus 1 square. Okay, that's 3. 3 to the power s. And what is on the right hand side you're going to get? R is 0 to 2s. X value you have plugged in once, so this. Don't you think it's the same thing, right? B naught plus B1 just written in a summation form, B2s. Okay, so what did we get from here? We already got that this summation, let me write it here again. And this is how much? 3 to the power s. Now, do we know what is summation of 3 to the power s? Yes, we do know, right? Because what it is? It's a geometric series. You keep on varying your s, okay, 3 square up to dot 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 where 3 to the power n. So what's the sum of a geometric series? A, the first term, that's 1, 3 to the power 0 is 1. A, r to the power n. Okay, r in this case is common ratio, 3. N is number of terms. So how many terms do I have? N plus 1. Okay, so r to the power n minus 1 upon r minus 1. That's your formula for geometry. So we end up in getting the numerator value. Very simple. It's this value. Okay, let's keep it. Now, what is next? We have to also figure out what's the denominator, right? Okay, so just check it out. Open the summation and see what you want. So you start from r is 0. So a naught, 0 plus 1, that's 1. Plus, if you plug in r here, I'm plugging, okay? R value to be 1. So this is a1 upon 1 plus 1, that's 2. And the last term would be a2n plus 1, and denominator would be 2n plus 1 plus 1, that's 2n plus 2. So this is what we want. And who is going to help us? Of course, right? This is going to help you. How? Because you see that what is the right hand side over here? You see what is the right hand side? The right hand side is a naught plus a1x plus dot dot dot, right? So now you see if you want a1 by 2 or a naught by 1, don't you think, suppose I integrate this, okay, term by term. So what happens to the second one for say this, right? Now do you see that if I plug in x is 1, I get a1 by 2. That's what I wanted. Moral of the story, that you have to integrate that. Okay, let's integrate that. So the whole thing, okay, in order to get rid of the constant of integration, we will just do definite 0 to x. Okay, so let's do that. 1 plus 2x, 1 plus x square power n dx. Okay, even right hand side you want to integrate. Okay. Now how do you plan to integrate this? Quite simple, right? You understand? Okay, you have to do just the substitution. Okay, you just substitute, this is t. So 1 plus 2x dx is equal to dt. Done. Okay, so what happens now to the limits? Okay, 0. When x is 0, your t is 1. And when x is x, you get 1 plus x square. That's your limit. Okay, and this dx would be your dt. And this is anyways t, right? So t to the power n. That's your integration. And on the right hand side, it's quite obvious. Okay, you just integrate it term by term. I mean, that was all the reason why we were doing this, right? This is what you're getting. Okay, the last one, a2n plus 1 x to the power 2n plus 2 upon 2n plus 2. Okay, 0 to x. Correct? Okay, now nothing left much, right? Because now you have to just integrate. What do you get? T to the power n integration is what? N plus 1 upon n plus 1, right? I'm just writing on the corner so that we just not have to write so much. Okay, so now upper limit minus the lower limit. Can I write directly? Okay, n plus 1 is for both of them. Upper limit Instead of t, you are going to write 1 plus x squared n plus 1. Minus lower limit is 1. So 1 to the power n plus 1. Okay, so minus 1. This is equal to how much? You just plug in upper limit here again. Upper limit, the same thing, right? If you put upper limit, you get the same stuff. And at lower limit, what's going to happen? 0, right? Okay, at lower limit, everyone is going to 0. Now, what's the last step? Yeah, you understand, right? Put x is 1. Okay, just put x is 1. What do you get? This is 3. Okay, so you get 3 power n plus 1 minus 1 upon n plus 1. And what do you get here? Just all the x vanishes. Okay, you just get what you wanted. A 2 by 3, right? And dot 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 up to what? A 2n plus 1 upon 2n plus 2. Done. Okay, so now we plug in. Okay, we got the numerator value right here. We got the denominator value right here. Let's put it here. So numerator value, we said 3n plus 1 minus 1 divided by 2. Correct? Here. And denominator value, this was the denominator, right? This value we got to be this. 3 to the power n plus 1 minus 1 divided by n plus 1. So what's my final answer? Yes, n plus 1 by 2. Okay, I don't want to make this video long, so let's get to other question in the next session. Okay, I will see you. Bye-bye.